In this video, we're going to introduce something which is known or is referred to as the cast diagram, which is really useful in solving trig equations at both National 5 and higher level. I'm going to ask you to copy down everything you see in this video. At the top of the screen, you can see the sine graph, cosine graph, and the tangent graph with all the annotations 0, 90, 180, 270, 360. What we're going to be working with today is we're going to be developing the idea of quadrants. So quad should hopefully make you think of a number. For example, if I said quad bike, hopefully you'd be imagining a bike with 4 wheels. So what we're going to do is see with each of these graphs, we're going to split them into 4 equal parts. Okay, so in order to do that, what we're going to do is we're going to separate each graph into 90-degree sections. So I'm going to do this here. This is just for the sake of this activity. Now I'm going to draw a wee line here, a wee dashed line here. So every 90 degrees, I'm going to draw a dashed line. Hopefully that's okay. And so in this quadrant here, the first quadrant, we're going to call that quadrant 1. In between 90 and 180, we'll call this quadrant 2, quadrant 3, and quadrant 4. We're going to do the same activity for the other graphs. I'm going to split them into 4 quadrants. And I just need to do a dashed line here to have that done. Okay, so we can mark on quadrant 1, the first quadrant, the second quadrant, the third quadrant, the fourth quadrant, and here quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so what we've got at the bottom here is we've got a table with sine, cos, and tan, and Q1, Q2, Q3, Q4, each corresponding to the 4 different quadrants. What we're going to record in this table is if the function is positive or negative in that quadrant, is the value above the x-axis or below the x-axis. Because, for example, if I ask you to type in a number, for example, sine of 70, I know that's going to be positive because it's going to be above the x-axis. If you typed that into your calculator, you would get a value that's bigger than 0. If you type in sine of anything in between 0 and 90, you're going to get a positive answer because it's above the axis. So in quadrant 1, sine is positive. In quadrant 2, so if I picked a value in between 90 and 180, say 170, if I typed in sine of 170, I would get a value that's above the x-axis, so therefore it's going to be positive. In quadrant 3, if I picked a value in between 180 and 270, maybe 200, if you type in sine of 200 into your calculator, you see you're going to get a negative number because it's below the x-axis. And lastly, in quadrant 4, if I typed in a number in between these two, for example 300, if I typed in sine of 300, I'm hoping you'll see that we're going to be expecting a negative answer. We'll do the same activities for cos and tan. In quadrant 1, cos is above the x-axis, so it's positive. In quadrant 2, it's below, so it's negative. In quadrant 3, it's below. And in quadrant 4, it is above. Finally, if we look at tan, in quadrant 1, it is above the x-axis. In quadrant 2, it is below the x-axis. In quadrant 3, it's above the x-axis, and in quadrant 4, it's below the x-axis. Okay, so there's a few wee things that we can take from this table that are hopefully quite interesting. See if we just zoom in on quadrant 1 here, you'll hopefully notice that all of the functions are positive. Do you see that? They are all above the x-axis. In quadrant 1, they are all positive. But see in quadrant 2, there's only one function that's positive. It's only the sine function. Do you see that? The other two are negative. The other two are below the axis, whereas sine is above. So in quadrant 2, only sine is positive. In quadrant 3, it's only tan that's above the x-axis here. And in quadrant 4, it's only cos that's above the x-axis. What we're going to do is we're going to try and summarise this table into something that we can replicate easily and quickly, and it's referred to as a cast diagram. And it's something that we're going to be using regularly to help identify angles when we're solving trig equations. Okay, so I'm going to ask you to draw this, make this quite big on your page. Might want to make it take up half a page if you want. If you want a wee heading, you can just call this a cast diagram. Okay, so what we're going to do is we're working with 4 quadrants, and hopefully you can see 4 parts. 1, 2, 3, 4. We're going to work anti-clockwise. Often in maths we do work anti-clockwise. So here we're going to call this quadrant 1. This is quadrant 1. This is quadrant 2. Quadrant 3. And quadrant 4. Okay, so in quadrant 1, we're going to start from this point here. So quadrant 1, we had the values from 0 degrees up to 90 degrees. In quadrant 2, we went from 90 to 180. Quadrant 3, 180 to 270. And quadrant 4, 270 to 360. Okay, so if we think back to the table that we've just noted down, in quadrant 1, they were all positive. Sine, cos and tan were all positive. So see, instead of writing all, we just write A. A stands for all. I'll maybe write this a wee bit clearer later on. In quadrant 2, only sine was positive. Cos and tan were negative. So see, in quadrant 2, we're just going to write S. In quadrant 3, it was only tan that was positive. And in quadrant 4, it was only cos that was positive. You'll be able to see that from the table of values. Okay, so A is short for all, S short for sine, T short for tan, and C short for cos. So this here is what is known as a cast diagram, and this can help us how to work out the sizes of angles when we're solving trig equations. Okay, I'm going to leave this here just now. We're then going to be working with this in quite a lot of detail over the next little while to help solve trig equations. Thank you very much.